So we will always have reactants, right, at the beginning and products at the end. And so we need to pay attention on few things here. This amount of energy or a barrier that we need to pass, right? That's a barrier for this reaction. How do we call that barrier? Does anyone remember that?
Activation energy?
Very good. This is activation energy. So activation energy is the barrier that reactants should reach to that energy to be able to form at the top of the graph, to be able to form, how do we call that? They need to form some like transition particles there, transition molecules. Activated complex, very good. Okay, so activated complex will be formed. Then, so effective collisions, remember the previous class, rate of the reactions. If part activated complex is formed with the effective collisions and energy, sufficient energy, then they will be able to produce new substances. And the final thing, let's look at the energy change on the graph. The energy of the reactants and energy of the products. That difference is the energy change. The change of energy, we're going to call it delta H. Change in heat, change in energy. And change for exothermic is going to be shown here. So, as you look at the graph, you will notice that the energy of products higher than energy of reactants. That means heat is absorbed or released, Fatima. If energy of products more than energy of reactants, heat absorbed, very good. So that's absorbed, heat is absorbed, that's why it is an endothermic reaction. And the second one, energy of products less than energy of reactants, then heat is released. That's why the second one is the graph for exothermic reaction. Okay, so that we are going to use the graph to determine whether it's endothermic or exothermic, or we are going to calculate the heat released, heat absorbed.